Okay, so this is our continuing discussion of Simondon's individuation in the light of notions of form and information. We're on part 1, chapter 2, and then section 2 within that chapter. So we saw last week, we were discussing the photoelectric effect, which is an effect that occurs when various metals are illuminated by a light beam. They emit electrons. This effect has some sort of paradoxical properties, and these were what led to the introduction of the notion of a photon as a particle of light. After in Einstein's paper in 1905, he first introduces this term. I don't think he uses the term photon, but he introduces the idea of a discrete quantity of action of light, which is what is now referred to as a photon. So in this in this section, the sort of introductory question that Simondon is posing is whether or not the notion of photon should be understood as referring to a real entity. So we can use it in physics. We can use it as a sort of as-if concept. We can calculate the properties and make predictions based on the conception of light as consisting of these corpuscles of energy, or these discrete components of light. But the question is whether we should grant that discreteness or corpuscularity of light a status of reality. And Simondon is going to argue that we should not. And this would certainly be a controversial position today. I think the general consensus among physicists is that their photons do have the status of reality. We'll see what arguments Simondon has to bring for that position. So that's the sort of framing question of this section, and then we'll get into some of the details. So basically, the structure of the argument is, first he sets out the motivation for the position for positing a photon. That's what we started seeing last week. And then he's going to explain why we shouldn't grant the status of reality to the photon in this sort of a second stage of the argument. Is a little bit compressed, I think, but we'll see it as we get to it and try to evaluate its validity. Okay, so we ended on page 102 last week, but we just read through some part of 102 pretty quickly right at the end, and we didn't have much time to discuss it, so we decided to go over it again today. So I'll start from 102, and then we'll go around with the reading as usual. Okay, so it starts sort of in mid thought here, so we have to remember from last week's discussion. Consequently, it could be supposed that luminous energy transforms in the plate into a potential energy that makes possible the modification of the state of relation of an electron with the particles that constitute the metal. This would make it possible to understand that the place of free electrons does not intervene in the determination of the phenomenon, no more so than the density of photons per unit of surface of the metallic plate. We will then be referred back to the case of the relation between a structure and an amorphous substance, which manifests as a continuum, even if it is not continuous in its composition. Here, the electrons manifest as a continuous substance because they submit to a distribution that conforms with the law of large numbers in the metal plate. This ensemble, constituted by the electrons and the metallic plate in which they are randomly distributed, can be structured by the addition of a sufficient quantity of energy that will allow the electrons to escape from the plate. The disorganized ensemble will have been organized. Nevertheless, this hastily presented thesis should be critiqued. There are, in fact, other ways of increasing the metallic plate's potential energy, for example, by heating it. Then, starting at temperatures between 700 degrees Celsius and 1,250 degrees Celsius, we witness a phenomenon called the Thermo-Ionic Effect taking place, and it is more appropriate to call it the Thermoelectric Effect. Electrons spontaneously escape from a piece of heated metal. When this metal is covered with crystallized oxides, the phenomenon takes place at a lower temperature. Here, the changes in distribution occurs without the intervention of any condition besides the elevation of temperature, at least in appearance. However, the energetic condition, namely the temperature of the metal that constitutes a hot cathode, is not sufficient by itself. The structure of the metal surface is also involved. In this sense, we presume that a cathode can be activated by the addition of metal traces, for example, those of strontium or barium. Thus, even in the thermoelectric effect, there are structural conditions for the emission of electrons. However, as in the case of an amorphous substance that passes to the crystalline state through the spontaneous and even today unexplained appearance of crystalline germs in its mass, the structural conditions of the thermoelectric effect are always present in ordinary conditions when these conditions are energetic. They are present at least on a large scale for a hot cathode with enough emitting surface, but they are present in a much more discontinuous manner on a small scale. All right, so he's bringing back some of the concepts from the previous chapter about the conditions for individuation, the 3/2 conditions. So sometimes we have structural, material, and energetic conditions, and sometimes the material and energetic are sort of combined together. So here he's looking at the emission of photons in the the emission of electrons, in the photoelectric effect, and trying to analyze this process in terms of the conditions that he had set out in the last chapter. So he says that we have something like an energetic condition in the sense that the free electrons in the metal play the role of a continuous amorphous substance. So even though the electrons themselves are discrete particles, the fact that they're operating in accordance with the law of large numbers means that they have a continuous effect. So they sort of simulate a continuum. As we saw in the previous chapter, we're talking about the amorphous substance, which is composed of many molecules, but acts as a continuum in the individuation process. So here it's the electrons that are, the free electrons in the metal that are acting as a continuum. And then he points out that, or he suggests that maybe this energetic condition, the addition of energy to this continuum, would be enough for the emission of an electron from the surface of the metal. And he says that this is only correct at a sort of first approximation because we find that there are actually certain conditions of the surface as well that will favor or disfavor the emission of electrons. So there is a structural condition in addition to the energetic condition. So the two sort of main conditions, there's no reference here to a material condition, but the two primary ones are still valid in this case as well. Okay. And another point is when he introduces this thermoelectric effect. So the name thermo-ionic is the one that's the standard name of this effect in physics, but it is, as Simonon points out, it's a little bit misleading because this effect consists in the way that metal will emit electrons if it's heated. So the photoelectric effect was light beam illuminating a piece of metal with a light beam will bring about the emission of electrons from the surface of that metal. And now we have the thermoelectric effect is when the metal is heated, it emits electrons. It's the same idea as in pyroelectricity in crystals that we saw mentioned in the last chapter. And the thermoelectric effect is behind various technologies like a vacuum tube, which involves heating a metal filament, and then that metal filament emits. That's the cathode end of the tube that emits electrons that are captured by the anode end of the tube. So yeah, this effect has a lot of technological relevance. So the reason why calling it thermo-ionic is misleading is because it's not actually ions that are emitted. It's the electrons that are emitted from the metal surface. But for whatever reason, the name thermo-ionic is the standard name for this effect in physics. So if you want to look this up and get more information about it, you have to look under Thermo-Ionic Effect. But yeah, so the reason for introducing this second effect is that the hypothesis that Simondon is discussing with relation to the photoelectric effect was that the light intervenes into the process of emission by adding to the potential energy in the continuum of electrons in the metal. Heating the electron, or heating the metal, sorry, would be an alternate way of increasing the potential energy of the continuum of electrons. So he's going to suggest in a little bit that we should see an interaction between the two effects. So it should be the case that heating a metal too close to the threshold for the thermoelectric effect should make the metal more susceptible to releasing electrons in the photoelectric effect if his explanation for the photoelectric effect is correct. And so that's something that I'm not sure if that's actually been experimentally tested. It would be interesting to look into that. He does, well, anyway, we'll get to that in a little bit, but he points out there's some obstacles to the experimental realization as well. Yeah, so the thermoelectric effect or thermo-ionic effect is introduced here as an alternate method of adding potential energy to the energetic condition or the continuum of the electrons in the metal surface. Right, so yeah, this bit is talking about the energetic condition of a process of individuation. And he points out or suggests that the thermoelectric effect looks as if it's the energetic condition alone that is operating. At sort of a first glance, it looks like that, but then he points out that there actually is a structural condition as well as the energetic condition, so that adding traces of different metals to that surface will bring about will make it more likely that electrons will be emitted, or will make the emission rate higher, or so on. We have both an energetic condition and a structural condition here. And the same thing he's going to make that same argument for the photoelectric effect as well. Okay, so let's go on to the next page or so of this multi-page paragraph. If someone else would like to read, and if you're muted and would like to read, just post something in the chat and I'll unmute you.
If by means of a focusing apparatus, an electrostatic or electromagnetic lens, we project onto the fluorescent screen electrons emitted at the same instant by the different points of a hot cathode, so as to obtain an enlarged optical image of the cathode, what we will see is that the emission of electrons by each point is extremely variable according to the successive instants. The emission takes shape like successive craters of intense activity, and these craters are highly unstable. If an anode is set up in proximity to the cathode in an empty enclosure with enough difference of potential to collect all the emitted electrons, saturation current, between the anode and cathode, the total current gathered shows fluctuations that arise from these intense local variations of the intensity of the thermoelectric phenomenon. The larger the cathode surface, the weaker these local variations are with respect to the total intensity. This phenomenon is perceptible in an electronic tube with a very small cathode. It has been sufficiently studied recently under the name of scintillation or quote-unquote flicker. However, all the points of a cathode are under the same thermal energetic conditions in approximation with very small differences as a result of the metal's elevated thermal conductivity. Even if we suppose slight differences of temperature between the different points of the surface of a cathode, we could not thereby explain the abrupt and important changes of intensity of the emission of electrons between two neighboring points. This is why the thermoelectric effect depends at least on another condition besides the energetic condition, which is always present. The bright and fleeting craters observed in the electrical optic apparatus described above correspond to the appearance or disappearance of this condition of activity on the cathode surface in a certain determinate point. The study of this phenomenon is not sufficiently advanced for us to specify the nature of these germs of activity, but it is important to note that they are functionally comparable to the crystalline germs that appear in a supersaturated amorphous solution. The nature of these germs is still mysterious, but their existence is certain. Nevertheless, we should ask if, in the photoelectric effect, lighting merely acts by increasing the energy of the electrons. It is interesting to note that electrons escape perpendicularly to the surface of the alkaline metal plate. It is rather regrettable that the elevated temperatures necessary to obtain the thermoelectric effect are not compatible with the conservation of zinc, cesium, or cadmium cathodes. For temperatures barely lower than those in which the thermoelectric effect begins to manifest, we could attempt to see if the minimum frequency of light producing the photoelectric effect would be lowered, which would show that the escape energy had lessened. If this were the case, it could be concluded that there are two terms in the electron's escape energy, a structural term and in fact a term representing a potential. I'm turning the page. However, even in the absence of more precise experiment, it is possible to glean from this example a certain number of provisional conclusions relative to the study of physical individuation.
This is the bit that I had mentioned previously, where he suggests an experiment. Well, actually, there are two different experiments that he suggests here. One which is that has been done, and one that at the time he was writing had not been done. And I'm not sure if it's been done since then. So the first setup is you have a hot cathode, so you have a piece of metal that is heated to the point of emitting electrons, and then you have a fluorescent surface, so a surface that emits light whenever it's struck by an electron. That allows you to obtain an optical image of the hot cathode. And when you do that, what you find is that there's a series of sort of flashes, he calls them craters, of activity on the surface, so that you get, if you have a rectangular image of the cathode, for example, you'll have different points of the rectangle will be lighting up at different moments, and so there's changing activity on the cathode surface that's reflected onto the that is shown on the fluorescent surface, and so he points out that the energetic condition is the same across the whole cathode. It's at the same temperature because metals in general have a high thermal conductivity. So the surface should all be at the same temperature with only very minimal variation of temperature. And even if we do suppose that there is a variation of temperature, it doesn't explain the very quick flash and then cut off of the flash. Temperature changes gradually, but we have these sudden appearances of these craters, as he calls them, and then a disappearance. So the energetic condition, the heat or the temperature of the metal is not sufficient to explain the effect. There's some sort of structural effect which he compares to the germ that brings about crystallization. So there's some sort of structural effect, but it's not known what exactly it consists in. This structural condition is mysterious, as he says. It's not hasn't been studied yet, but something about the surface brings about the formation of these craters or these bright flashes of activity of emission of electrons successively in one place and then in another over the surface. So the point here is basically that that there's the second condition, the structural condition, in addition to the energetic condition in the thermoelectric effect. And then he goes on in the second half of the page to look at or ask the same question about the photoelectric effect. So is it the case that the photoelectric effect acts just by raising the potential energy of the contained in the continuum of electrons, or is there a structural condition in the photoelectric effect as well? And then he points to what would be a possible experimental test would be to heat the metal to a temperature close to the threshold for the thermoelectric effect, so just below that threshold, and then try to produce the photoelectric effect. And he's predicting that, or he's suggesting it would be interesting to try to find out whether the photoelectric effect has a lower threshold frequency when the metal is heated, which would suggest that both the photoelectric effect and the thermoelectric effect are acting by increasing the potential energy in the metal. And so there would be a sort of reciprocity of one to the other, that if you raise the potential energy through heating the metal, that means that it takes less energy to make the metal emit electrons. But he points out that this experimental test would be made difficult by the fact that metals like zinc or cesium or cadmium are not the melting point is below the point where the photoelectric or the thermoelectric effect occurs, so that you can't have a cathode made of these metals that would be able to be maintained at that temperature. So I'm not sure if there's a way around this, some sort of experimental setup that would be able to get around this issue. I guess potentially you could have a liquid metal surface and have that undergo the photoelectric effect and see what happens in that situation. But yeah, I'm not sure if this has been tested or not. Yeah, and Angus made a comment in the chat about the way that in this example, the structure seems to be already present in the metal, and it's the energetic condition that changes around it. Whereas in the case of the crystallization example, it was the energetic condition that was structured by the introduction of a germ. I'm not sure if that is exactly right, because here, so in both cases, we have a germ that appears in this sort of mysterious way. And we saw in the form information potentials text discussion that we read a couple months ago. He sort of suggests that there might be something like a role of chance in the formation of these structural germs, but then he sort of he says something like, I hesitate to ascribe a role to chance in this process, or something like that. I don't remember the exact wording, but he points to something like chance, but then kind of hesitates to actually posit that role of chance. So in both the crystallization example and the example under discussion here, there is this appearance of these structural germs, which then brings about a structuring of the energetic condition, or which interacts with the energetic condition to bring about a structuring of the amorphous substance, in this case, the swarm of electrons. So I think in both cases, it's the structuring germ that brings about the structuration. So I don't think the structure is already inherent in the metal. It's so it's this new germ that appears that brings about the structuring process. Okay, so I think we can go on to the next page if someone else would like to read. Indeed, we see a very remarkable type of relation in the photoelectric effect. From an energetic point of view, all the free electrons that are in the illuminated metal plate are like a single substance. Otherwise, we would be unable to understand how there could be an effect of the accumulation of luminous energy arriving on the plate up to the quantity of energy necessary for the escape of an electron to be received. There are cases where the phenomenon cannot be considered as instantaneous. Thus, in this case, the luminous energy must have been stored in reserve beforehand. On the other hand, this energy supposes a communication between all the free electrons, where it can be conceived with great difficulty that the energy has been supplied by a photon that would have taken longer to act on the electron than the speed of light would allow us to calculate. If the relation between light and an electron occurs more slowly than the speed of light allows, this is because there is no direct relation between light and the electron, but a relation through the intermediary of a third term. If the interaction between the photon and light is direct, it must be short enough for the photon between the beginning and end of the interaction to still be practically in the same place. Here, for the displacement of the photon, we are limited to rehashing the reasoning that has led to the adoption of the idea that the photon can manifest in any illuminated point. But if it is acknowledged that the photon can manifest its presence everywhere at the same instant on a plane perpendicular to the direction of displacement, it cannot be acknowledged that the photon can stay in the same place during the entire duration of a transformation. If, for example, a transformation lasts 1/100th of a second, the photon would have had enough time to travel 3,000 meters between the beginning and the end of this transformation. This difficulty is avoided if we suppose that between the light and the electron, energy is summated in the milieu in which the electrons are. This summation could occur, for example, as an increase in the amplitude of an oscillation or in the frequency of a rotation. In the latter case, for example, the frequency of light would intervene directly as a frequency and not as a scalar quantity. If a direct role of frequency is admitted, we no longer have to represent a photon whose energy would be represented by the measure of a frequency. Frequency is the structural condition without which the phenomenon of structuration cannot take place. But the energy intervenes as a scalar quantity in the number of electrons extracted per unit of time. According to this representation, it would be necessary to consider an electromagnetic field as possessing a structural element and a pure energetic element. Frequency represents the structural element, while the intensity of the field represents its energetic element. We are saying that frequency represents the structural element, but not that it constitutes the latter. For in other circumstances, this element will intervene as a wavelength during a propagation in a determined milieu or in a vacuum. A diffraction by the crystalline network involves this structure as a wavelength relative to the geometrical length of the crystalline lattice. So here he's bringing up reasons to think that the relationship between the photon or the light impacting the metal surface and the electrons within that metal surface, he argues that this interaction is not a direct interaction, but it's mediated by a third interval, the medium in which the electrons occur. So there's something like the electric field in which all the electrons are contained and that they interact with. There's something like a structural element to that field, so that the light is interacting with the field itself, and only through the intermediary of the field does it interact with the electrons. And the reason for that he suggests for this is the time interval that it takes for this interaction to occur. So the photon concept was supposed to explain how this energetic transfer occurs, or the transfer of energy occurs from the light beam to the electron in this discontinuous way. So that it's only if the if the light is of a certain frequency, is above a certain frequency, the threshold frequency, then the photoelectric effect occurs and there's an emission of electrons. But below that frequency, there's no photoelectric effect. So there's a discrete on-off sort of effect. And so that's what the photon concept was introduced to explain. But the problem is that the photon is supposed to be traveling at the speed of light. So if the interaction between the photon and the electron is taking place in even as short an interval as 1/100th of a second, then the photon still has enough time to travel 3,000 meters during that time interval. So you can see already that if the interval is any longer than that, then you have even greater distance that the photon is going to be traveling in that time. So the fact that the emission of electrons takes time suggests that there's something like a summation that's going on. So the field is absorbing energy over a period of time, and then once it reaches that threshold, it will emit, where one of the electrons will be emitted from the surface of the metal. So there's that summation effect over time, which constitutes the and then the second point that he makes there after the introduction of the thesis of the summation effect, the second point is that this summation can be thought of as an increase in amplitude of an oscillation or a frequency of a rotation. So if we have something like an interaction between the light and the electron, in which the frequency is one of the components, we are now able to represent that frequency as intervening in the process as a frequency and not just as a scalar quantity. So in the more standard representation, the frequency really only intervenes as something which is multiplied by the Planck constant to give us the energy of the photon and what energy it contributes to the potential emission of an electron from the metal surface. But in this suggestion, if we understand the summation process as something like the increase in frequency of a rotation, then the frequency of the photon would actually be intervening in the process as a frequency and not just as a scalar quantity. So that this frequency aspect in the field would be the structural element, would represent the structural element, as he puts it. He's a little bit more careful than that. And then the intensity of the field would represent the energetic element. So there would be both a structural element of the field, which corresponds to frequency, and an energetic element of the field, which corresponds to the intensity of the field. So he's again positing these two conditions, the energetic and the structural, and he's leaving out the third condition that he had pointed to in the case of the crystallization example, the material condition. So the question from Angus in the chat is, when Simondon says that that frequency represents the structural element, is he just clarifying that this is the structural element in this case, but not others? I think what he's suggesting is that the structural element appears in the form of frequency in certain circumstances, like in the case of the photoelectric effect, but it appears as wavelength in other circumstances. like in the case of the diffraction by a crystal, as he points to at the top of 105. Um, um, but wavelength and frequency are reciprocal of one another. So this is a little bit pedantic, I think, to make this distinction, or to sort of insist that we only say it represents the structural condition. Um, so wavelength is the reciprocal of frequency, so that the in the case of the diffraction of the crystal, you can still represent it in relation to the frequency. You just have to flip the equation over. So it's not, it doesn't make that much difference one way or the other. I'm not sure if there's anything other than frequency or wavelength which plays this role of representing the structural element in the field. If there is, then it would make more sense to say that frequency only represents the structural element, but he doesn't give us any other examples at this point. And they're going to have, we're going to see more about frequency in the rest of this subsection. So he's going to give a further justification for wanting to understand frequency as acting in the process, in the photoelectric process, not simply as a scalar quantity, but as a frequency as such. So we'll see more on that in the next little bit.
I can read again. We're on the top of page 105. The interest in a representation of structure linked to frequency is not merely that of a greater realism, but also that of a much broader universality that avoids creating arbitrary categories of electromagnetic fields, something that seemingly ends in quite a paralyzing substantialism. The continuity between the different manifestations of electromagnetic fields of varied frequencies is established not just in theory, but also by scientific and technical experimentation. If, as Louis de Broglie does in Ondes Corpuscules Mécaniques Ondulatoires in Figure 1 between pages 16 and 17, we inscribe via logarithmic scale of frequencies the different discoveries and experiments that have made the measurement of an electromagnetic frequency possible. We see that there is a fully established continuity between the 6 domains initially considered to be distinct: Hertzian waves, infrared, visible spectrum, ultraviolet, X-rays, and gamma rays. As technicians, we're going lower in frequency with the domain of waves theoretically discovered by Maxwell and effectively produced by Hertz in 1886 with a decimetric oscillator. Righi, an Italian physicist from Bologna, establishes the existence of waves measuring 2.5 centimeters. In a work published in 1897, he showed that these waves are intermediary between visible light and Hertzian waves. They possess all the characteristics of visible light. The title of this work, Optique des oscillations électriques, is quite important, for it shows an attempt to unify two domains that were at that time experimentally separate, although they had been conceptually joined together in Maxwell's remarkable electromagnetic theory of light, optics, and electricity. Following the path opened up by Righi, Bose and Lebedev endeavored, with the aid of the apparatus Bose constructed in 1897, to repeat Hertz's experiments on the refraction, diffraction, and polarization of electromagnetic waves. These two researchers managed to produce electromagnetic waves 6 millimeters long. In 1923, Nichols managed to produce waves 0.29 millimeters long. 1 year later, Glagoleva Arkadeva attains 0.124 millimeters. And yet, through optical methods, Rubens and Bayer in 1913 had already been able to isolate and measure a radiation of 0.343 millimeter wavelengths in infrared radiations, surpassing the simple analogy of the properties of propagation. The two forms of energy previously isolated as two genera, or at least two species, would partially overlap in extension from 0.343 to 0.124 millimeters of wavelength, and would be identical in comprehension as much for the genesis as for the study of quote-unquote properties, thus showing the fragility of the thought that proceeds via common genus and specific difference.
Right. I posted in the chat a picture of the electromagnetic spectrum, which is what is being discussed here. So again, we just saw the introduction of the notion of frequency acting not as a pure scalar quantity, but as frequency as such. Simondon's argument for this hypothesis is, well, first he suggests that it's introduces a greater realism, but he also suggests that it allows a greater universality, precisely because we can represent all the frequencies along this spectrum as part of as involved in the same type of operation. Basically, what he goes through here is a history of the filling in of this diagram. So what happens is that you have different physical processes that emit radiation at different wavelengths. And over time, physicists were able to extend the range of the wavelengths produced by different processes until they overlapped. What he calls here Hertzian waves or radio waves is what we would call it, come to overlap with infrared radiation produced by optical means. And so there's an overlap between the one and the other. And we have the same type of phenomenon that happens with other portions of the electromagnetic spectrum. And what that shows is that there's a continuity across the electromagnetic spectrum, so that there's no inherent difference between one portion of the spectrum and another. The differences that we or the different categories that we attribute to visible light or gamma rays or microwave radiation or whatever other forms, those are all relative to human biology or various technical operations that we use to produce electromagnetic radiation in that wavelength. But there's a continuity across the whole spectrum in terms of the fundamental physical reality at work. And then he introduces, or he just mentions here that this mode of thinking doesn't operate by genera and species. So it's not that electromagnetic radiation is the genus, and then the species would be visible light and microwave radiation, etc. It's actually a continuum where all the basic physical properties of the electromagnetic spectrum are the same across the whole continuum, and we only divide it up in various ways for technical purposes. So we've seen, I think, previously a few occasions where he's criticizing genus and species classification as a mode of thinking. So this is another instance of that, and he's going to introduce transduction, or he's going to point to the transductive nature of this process through which the spectrum is filled in. And now maybe I'll say a little bit more about the transduction here. It's always, for Simondon, it's always contrasted with induction and deduction. And what's characteristic of induction for Simondon is the way that there's an inverse relationship between the comprehension and extension of concepts, so that as a concept becomes more precise, it gains in comprehension. So there's more there are more properties that are subsumed under that concept, or the concept itself becomes richer, you can say. But that means at the same time that fewer entities fall under that concept. So if you start from a concept like mammal, and then you introduce I don't know, a particular kind of mammal, a dog has more. The concept dog has more richness or more attributes more properties to something than the concept mammal does. But then there are fewer individuals that fall under the concept dog than the concept mammal. So there's this inverse relationship. The more entities fall under the concept, then the less comprehension the concept has. And then the more comprehension a concept has, the fewer entities fall under it. And this inverse relationship is characteristic of induction. So we proceed from individuals, we abstract away from certain of their properties so that we can classify them under a shared concept, and then we do the same thing with those concepts to produce the genus under which they fall. So again, this is not what happens when we have the concept of the electromagnetic spectrum, because we don't. There's no such thing as there's not a genus electromagnetic wave and then a species of visible light and radio waves and so on. They're all continuous, and it's just the difference in wavelength or frequency that is what passes from one form of radiation to another. And again, it's not a deductive process, because we're not starting from one form and then having something like what Simondon calls a transfer of evidence from one form of electromagnetic radiation to another. So in a deductive process, we would start from something like a universal, and then we would deduce the properties of the specific from the universal under which it falls. But that's not what we're doing when we think about the electromagnetic spectrum. We have, again, this continuity rather than species and genus classification. Okay, so I think we can go on to the next bit. If there are any volunteers to read, if not, I will read again. You're making me do all the work today. It's okay. So yeah, we just saw the sort of a sketch of a history of the ways that the different portions of the electromagnetic spectrum were discovered, and then how the gaps between those different portions were filled in over time. And so we're continuing from there. Okay. Common genus and specific differences here are on the same level of being. They both consist as frequencies. Extension and comprehension also overlap, for the statements of the limits of extension utilizes the same characteristics as definition through comprehension. The intellectual course that the progressive discovery of the continuity between Hertzian waves and the visible spectrum manifests is neither inductive nor deductive, it is transductive. Indeed, visible light and Hertzian waves are not two species of a common genus that would be a genus of electromagnetic waves. No specific difference can be indicated to allow us to pass from the definition of electromagnetic waves to that of Hertzian waves or visible light. There is nothing additional in the definition of Hertzian waves or of light than in that of electromagnetic waves. Extension and comprehension do not vary in the inverse direction as in induction. Furthermore, it can no longer be said that this thought proceeds like deduction through a transfer of evidence. The properties of luminous electromagnetic radiations are not deduced from the properties of Hertzian electromagnetic waves. They are constituted based on the very measure that allows for both a distinction and a continuity to be established, that of frequency. It's because their only distinction is between the frequency and its inverse wavelength that these two physical realities are neither identical nor heterogeneous, but contiguous. This method of transduction allows for the establishment of a topology of physical beings that neither studies genera nor species. The criterion that allows us to establish limits for each domain also allows us to define in inductive language what the subspecies would become without the addition of any new distinctive characteristics, and simply through a specification given to the universal nature of comprehension. Thus, in the previous example, if we want to account for the differences that exist between centimetric electromagnetic waves and decametric electromagnetic waves, we will have to resort to this characteristic that will allow us to say why the separative power of an optical microscope is greater in violet light than in red light. It will be revealed that the reflection, refraction, and diffraction of an electromagnetic wave depends on the rapport between the order of magnitude of the wavelength and that of the elements of the matter constituting the mirror, diopter, or network. If we take the example of reflection, for instance, the condition for this phenomenon to occur is that the mirror irregularities must be smaller compared to the wavelength of the electromagnetic emission to be reflected. The optical luster of silver or mercury is necessary for reflecting the violet light of short wavelengths. On the other hand, red light is already suitably reflected by a less highly polished metallic surface. Infrared radiation can be reflected by a plate of lightly oxidized copper. Centimetric radar waves reflect off a non-polished metallic surface. Decimetric radar waves reflect off a finely netted metallic lattice. Metric waves reflect off a trellis of metallic bars. A trellis with broad links made of cables suspended from pylons, or even a row of pylons, suffices for the reflection of decametric or hectometric waves. Similarly, it takes the minuscule structure of a crystalline network to diffract X-rays, whereas a network made of lines delicately hand-carved on a plate of metal is enough to guarantee the diffraction of visible light. The metric waves of television diffract off the crenellated peaks of the Sierra Mountains, which is a natural network of very large cells. More complex properties, like the rapport between the quantity of energy reflected and the quantity of energy refracted for each wavelength that encounters a semiconductive obstacle, like the complexly structured Kennelly heaviside layer, can be interpreted using a similar method that is neither inductive nor deductive. The word analogy seems to have taken on a pejorative meaning in epistemological thought. However, veritable analogical reasoning should not be confused with the completely sophistical method that consists in inferring identity from the properties of two things that have any characteristic in common whatsoever. The veritable analogical method is rational to the extent that the method of resemblance can be confused and untrustworthy. According to the definition of Bruno de Solage, veritable analogy is an identity of rapports and not a rapport of identity. The transductive progress of thought effectively consists in establishing the identities of rapports. These identities of rapports strictly are not at all based on resemblances, but are instead based on differences, and their goal is to explain the latter. They tend toward logical differentiation and do not at all tend toward assimilation or identification. Thus, the properties of light seem quite different from those of Hertzian waves, even in a limited and specific case like that of reflection on a mirror. A trellis does not reflect light and reflects Hertzian waves, whereas a small, perfectly polished mirror reflects light and almost does not reflect a metric or decametric Hertzian wave at all, and certainly not a hectometric wave. To account for these resemblances or differences is to resort to the existing identity of rapports between all the phenomena of reflection. The quantity of energy is large when an obstacle, constituted by a substance whose singularities are small with respect to the wavelength of electromagnetic energy, is interposed into the trajectory of the electromagnetic wave. I'll stop there because I'll have to keep reading if I don't. So this bit on induction and deduction is what I was talking about earlier. So that inverse relationship between comprehension and extension doesn't obtain in this case of the electromagnetic spectrum. And so that's why we have, or that's what shows us that we have a transductive process of thought and not a inductive or deductive process of thought. So as he says, it establishes a topology rather than a genus and species relationship. Right, and then the other, so the set of properties that appears in relation to the electromagnetic spectrum, he points to reflection as the example. So that reflection occurs when the surface in question or the object in question is much smaller than the wavelength of the electromagnetic radiation in question. So in the case of visible light, you need to have a polished metal surface. So silver or mercury are metals that are used in mirrors. Whereas if you're using radio waves, like in radar, it will reflect off of even a non-polished metallic surface. And then as you get longer and longer wavelengths of electromagnetic radiation, it will reflect off of even like in the longest waves will reflect even off the set of peaks of a mountain range, which acts as a mirror for those very long wavelength radiation. So again, the property of reflection is not something that is that can be understood in terms of genus and species. It has to be understood in relation to wavelength as this continuum in connection with the continuity of the electromagnetic spectrum. Right, and then he passes on to analogy, and if you remember in the introduction, previously in the book, he's referred to transductive thinking as what is valid about analogy, so that there is this maybe a pre-rational use of analogy in the form of an identity of rapport or thinking in terms of resemblance. So you understand one thing in an analogy to another because they share some property. They resemble each other in this way. And this is a confused thinking for Simondon. It's an untrustworthy way of thinking, but transductive thinking is not the same thing as merely identifying a resemblance between two entities. It has to do with a rapport of identity or relation of identity between them, so that what it means is that the relationship that obtains in one entity is analogous to the relationship that obtains in another entity. So we have the relationship between the wavelength of light and the property of being reflected from a surface in one instance. And then in another wavelength of electromagnetic radiation, say radio waves, we have another property of being reflected by entities with that wavelength. So I have Al Dreams has a hand up. Oh, I thought I had unmuted you already. Sorry.
I guess what I'm thinking about is what kind of difference are we talking about here when it comes to transduction? I think that's really interesting. So if we take the species genus model, I guess the way difference works there is it seems to be like a difference of negation. Something like, this is not that. And so, we have mammals, but then some mammals are, I guess some mammals have fur and others don't, right? So that could be, I guess, one specific difference. I guess, I mean, that's sort of my speculation. So, we could distinguish between furry and non-furry mammals, and then we can keep going, breaking down the taxonomic tree, and I'm wondering. So, if we don't use that model, then in what way are we thinking of difference here? And there was a line somewhere, I can't remember now, but I think he says something to that effect here. And I was also thinking. Deleuze discusses this quite a bit in Difference and Repetition, this topic. And one example that he brings up, and I wonder if this may be relevant here, is the example of the two hands. which I think is from Kant originally. So if you have a left hand and a right hand, there is obviously a difference there, but the difference, it turns out, you can't really express it in concepts. So I don't know that I understand that example all that well, but it seems like there's something about, like, it's a difference that you can only kind of, I don't know, you can't name it a priori. You have to, I don't know, somehow be immersed in those differences, and that's how you generate the knowledge of it. And that's my sense of maybe how transduction works.
Hello, can you hear me?
Yeah.
I was just going to say, I think that you're sort of right about that, Aldreams. I was going to say before, I don't know if it was, maybe I missed it or misheard, but I think it's rapport of identity rather than identity of rapports, isn't it? From the text. Anyway, I'm not sure. I'm sorry, I'm tired. But the question I was gonna, or so the way I was gonna intervene on this was, I was reading a little bit of the Coombs before this, and she talks about the analogy being about bringing to, I think she calls it bringing operative relations together, and that the way that you do that when we're thinking about genus and species, it's interesting that you started from the point of contrarieties, as Angus put it, because I would think that the place that you would start with genus and species is exactly the thing that sort of, I think, Simona critiques with identity and resemblance, of sort of saying, okay, well, this is this larger category, and then this thing sort of seems to resemble this thing, and so they must be part of the same category, or they must be related to the same idea, or whatever it might be. But when he's saying this, like, you have to grasp the process by looking at things that are differential, that do not appear to resemble each other. I guess it's an interesting approach here, because it's, again, like, at what point in the frequency spectrum could you point to an individual? Even in the Simondonian sense, like, you can't really point to an individual that you could then connect to another individual and say, okay, these seem to resemble each other, and therefore they must be of the same sort of like piece, or they must be of the same nature. It's sort of like you have to be able to look at these things which seem to almost operate entirely differently, and not see them as entirely different things, but starting from an original intuition, scientifically informed, but an original intuition that there is this process which undergirds all of it. You need to then understand how the discontinuities, it almost strikes me like an earlier statement when he was saying, probably differently, meaning something different here, but when he said, that we have to be able to conceive of discontinuities as part of a process, or as discontinuities as not sort of meaning that there's just separate things, but they're all part of a metastable process. Anyway, I'll try to get the identity of rapport thing down in the text, because I was confusing myself with that.
Right, yeah. He does say veritable analogy is an identity of rapports and not a rapport of identity. So the way I take it is that, so a rapport of identity would mean to group a number of entities under one concept and say these are all trees, or these are all dogs, or whatever the concept is. And so they would all be related to each other in under this rapport or relation of identity. They would all be identical as dogs, or as trees, or whatever. But what he wants to point to, what is the true form of analogical thinking, is an identity of rapports. So within each entity, there's this rapport that constitutes it. And then those rapports are related to each other in this transductive way, rather than something like a genus and species relationship. I may have said it backwards at some point, so sorry about that. But yeah, it's identity of rapports, not a rapport of identity, is the one that is the correct mode of thinking for Simondon, the transductive mode of thinking. And Aldreams, what you brought up about that Kant example of the two hands, that's funny because that example keeps coming up in different things that I'm reading or in different reading groups that I'm involved in. So I remember in Difference and Repetition, Deleuze points to that example as an instance of difference without the concepts or extra conceptual difference, where and so for Kant, that example is supposed to show that that space is something extra conceptual. It's not, and so this is an argument against Leibniz, because Leibniz understood space to be a purely relative phenomenon, so that space just reflects the arrangement of entities, basically the relations between entities. And so Kant points out that we have a right hand and our left hand can have all the parts of the hand can have the same relations to each other, but there's no way of getting one to the of turning one into the other through space. You can't make them coincide. And this also has relations to group theory in terms of the structure of space and so on. So this is anyway, it's a very interesting example that Kant brings up, and there's a lot you can go into in discussing it. But I think in relation to Simondon, he doesn't want to allow for something like this extra conceptual difference. I don't think, except in the sense. So Simondon sometimes uses the word concept in a technical sense to mean thinking in terms of species and genus, and then he contrasts that to transductive thinking, which is not conceptual in that sense. But I think what he wants to do is to precisely have a conceptual knowledge of the difference that would lie outside the concept otherwise. And he thinks that, as we've seen, he thinks that we can have an actual physical knowledge of individuation and of that difference that is not sort of extra conceptual. So we can have a true knowledge of the difference that would have to lie outside the concept under the genus-species model.
I have a question. I mean, regarding like a report of something, I can't refer to the exact term, but the thing is that my question is that I'm wondering, like, is that the extension of the characteristic? I mean, like something hidden, or is that finding the something hidden? Like what I mean here is that, like in terms of similarities, it can be on the surface, and then under the surface, a lot of different differences are hidden, and then that constitutes all the representative identification. I mean, manifestation. I lost my word. And the point here is that kind of like kind of confusing. What I want to say is like the mixture of similarities and differences. Like we can see something representative on the surface, and is that kind of like an extension of a particular.
Yeah, no worries. You can sort of reformulate your question. But I think if I understood sort of what the direction was that you were going in, when you talk about the way that resemblance can be a sort of a surface resemblance, and then there's an underlying difference. So he's going to, on the next page, I think, or very soon, he's going to bring up the way that physicists understood a resemblance between sound waves and light waves. So they modeled light waves on sound waves because of certain shared properties. So they were classing them under one concept as waves. But Simondon points out that there was a more fundamental, or there was underlying this similarity of in terms of both light and sound being waves, there was a difference between them because light waves are transversal, whereas sound waves are longitudinal. If you try to represent light waves as longitudinal, then you end up with problems that you can't really resolve that way. So you have to represent light waves as longitudinal. So you have to introduce something that is a disanalogy or that is a lack of resemblance between light waves and sound waves. I think that's why Simondon describes thinking in terms of resemblance as being untrustworthy, in that you can sort of notice a resemblance between one phenomenon and another phenomenon and say these two things are, I'm going to class them under the same concepts, and therefore they share all these properties. But then you can discover afterwards, oh, actually they don't really share all these properties that I thought they did. They only share the one property that I took as the basis of that resemblance between them. And then you have to sort of reformulate your concepts. Whereas in the case of transductive thinking, you rather than proceeding from a resemblance, you're proceeding through something like a continuity, a real physical continuity, like the electromagnetic spectrum, and you're representing the relationship between different portions of that continuum in thought, in the same way that they appear in the real physical continuity. It doesn't have that same untrustworthiness about it.
You really helped me to clarify my thought. Actually, that's the point what I wondered. And then, if I ask one more further question, it's like, does it have to do with some kind of pre-individuality? Like, I think like it depends on like what kind of pre-individuality, like for example, an individual or on kind of an entity had, like the extent of the extension, or the possibility of the transformation, or something like that. That could be dependent upon like pre-individuality, the kind, and then the quality, or something like that.
Yeah, I think you're right that there's a sort of presupposition of something like a pre-individual continuum here, and so it's only after the fact that we can, I guess, show that that presupposition was valid. So in the case of the electromagnetic spectrum, we can bring about experimentally the overlap between the different domains of electromagnetic radiation. So we can produce infrared radiation that overlaps with radio waves, and then we show that they're part of one spectrum. But yeah, so it's only after the fact. So this operation of thought, this transductive operation of thought, only comes into play after the experimental production of the phenomena has happened. So it's capable of verifying, or it can be verified through this experimental process. But in other cases, we won't have quite as straightforward a relationship between the transductive, the pre-individual continuum, and the transductive thinking that happens afterwards. So it'll be a little bit harder to verify that presupposition of the pre-individual continuum.
I just wanted to say that I feel like that actually is really relevant, because if you think about what we've been discussing sort of since the beginning with ontogenesis and individuation and stuff, like if you think about the example of the crystal, I feel I'm not sure if this is sort of getting in the right direction, but it seems to me that if you take like the supersaturated liquid and the crystal that forms, between these two things, if you're strictly operating on terms of analogy, you would never put those two things in relationship, except maybe from a sort of strict like linear time point of view of that this one thing used to be the other thing, but now it's something completely different. Whereas something like the pre-individual, what's interesting about it is the fact that it remains different. So not only that it remains, because it remains throughout the metastable process, so it doesn't go away, it doesn't just become something else and then it no longer exists, but as it continues to exist, it remains different from what it individuates and from the individual. And in the living being, like the examples he gives, like the pre-individual potentials, I guess if you want to call them that, continue to be drawn on for further individuations. But there continues to not be a strict resemblance between the different aspects of the system, it seems to me. And so it's important to kind of, if you're ever going to put those things in relation, it's like Aldream said, you always need to think from the point of view of relation in the first place. Relation has to have the status of being, because if it doesn't, then these are all just sort of accidental observations, and these things are only related insofar as they might have been states of one another at different points. But I think Simondon is trying to say, well, no, their difference and their ability to, phase shifts and all these things, like it's important that they don't necessarily remain in perfect harmony or resemblance throughout the process, and it's what allows the process to be what it is.
Yeah, I think that's a good way of putting it. And I think this is connected also with what Simondon draws, I think, from Bergson, the criticism of the notion of possibility, which would be something resembling reality. Like it would be the traditional concept of possible worlds are yes, it was me that brought up Bergson and not you. But yeah, so the traditional concept of possible worlds is a state of affairs that resembles the actual state of affairs, but with whatever small difference. And this notion of possibility, I think, is something that Simondon wants to get away from, and instead use this notion of potential, which doesn't necessarily resemble what comes to be or the actual state of affairs. So we have this non-resemblance relationship between the potential and the actual, rather than this sort of resemblance relationship between the possible and the actual. So I think that's connected as well. Okay, yeah. So let's go on to where did we get to? I think we're right at the top of 108, if I'm not mistaken.
There is identity of rapport between, on the one hand, the light wavelength and the dimension of irregularities of the mirror surface, and on the other hand, the Hertzian wavelength and the length of the elementary lattice of the trellis off which it reflects. The transductive method is therefore the application of veritable analogical reasoning. It excludes the notions of genus and species. Conversely, an illegitimate use of reasoning through resemblances is noticeable in the attempts to assimilate the propagation of light to that of sound based on several resemblances, like their reflection on the same mirrors. A watch is placed in the middle of a parabolic mirror. A second similar mirror would allow us to obtain an auditory image of the watch in the middle of the second mirror. It took Fresnel's strength of mind to stop this improper identification by demonstrating that there is a stark difference between the propagation of sound and the propagation of light. Light's elongations are always transversal, whereas those of sound propagating in a gas are always longitudinal. The differences between sound and light in phenomena of polarization were misunderstood due to an identification founded on the most external but also most striking resemblances. This facility that brings us to reason through identification according to resemblances stems from substantialistic habits that lead us to discover not yet known common genera through a random transference of properties. Thus the notion of ether, which was invented to further perfect the resemblance between the propagation of sound and that of electromagnetic waves, survived well after the experiment of Michelson and Morley and the quite illogical synthesis of the physical properties it conveyed. It was preferable to suppose the existence of a weightless fluid without viscosity with even more elasticity than steel, to be able to conserve the identity of light and sound. Scientific thought is not a pure induction achieved by a classification founded on differences, but it is also not an identification at all costs. It is instead the distribution of the real according to a measure, a mutual criterion of extension and comprehension.
So this is what I had just mentioned about the resemblance relation between sound waves and light waves, and the way that in earlier representations, light was depicted as a longitudinal wave, whereas we have to instead represent light as a transversal wave. So this has to do with the direction of propagation of the wave. So in a sound wave, the wave is propagating in the direction of the the wave is in the same direction as the propagation of sound, whereas in a light wave, the wave is perpendicular to the direction of propagation of the ray of light. Another example is the notion of ether, which was introduced in 19th century physics as the medium, or actually, sorry, it pre-existed that, but it was sort of widely used in 19th century physics as the medium in which light waves would operate. So that in the same way that a wave in water has water as the medium, so it consists in the motion of particles of water. In the same way, ether would be the substance which light waves would be a deformation of. What they found over the course of the 19th century was that you ended up having to attribute some very hard to reconcile properties to the ether. And in particular, so the Michelson-Morley experiment occurred in the beginning of the 20th century. And it's, if I remember correctly, it had to do with trying to measure the relationship between the speed of light in relation to the Earth's movement, so that if the Earth was traveling in the same direction as a light wave, then their speeds should add together, the speed of the Earth and the speed of the light wave. Whereas if the Earth was moving perpendicular to a light wave, then the speed should be independent of the motion. Sorry, I'm not explaining that very well, but what they found essentially was that the speed of light didn't vary with the motion of the Earth. So they ended up having to understand the ether as they had to posit these properties of incompressibility of the ether, and so on. So it was this very strange substance which would underlie the waves that we know as electromagnetic waves. And then it's only after the introduction of special relativity that, actually, I think it was general relativity, that really sort of put to rest the idea of the ether, so that electromagnetic radiation is understood as not as a wave in an ether, but a wave in the electromagnetic field. And so that's really all there is. It's just these fields, and there's nothing, no substance underlying the field. And so this is another example that Simondon gives of the untrustworthiness of thinking by resemblance. It was based on the resemblance between waves in or light waves, and then waves in other substances. So the assumption is that we need to have a medium.
Yeah, what I'm trying to figure out with transaction. So to my mind, it's fairly, discussions that we had earlier explain to me why this is not an a priori reasoning, right? It's not like we have this categorical structure that we begin with and we kind of impose it on things, but it's actually an immanent kind of thinking. What I'm struggling a little bit more with is distinguishing it from induction. And so we said there is that with induction, there is this inverse relationship of extension and comprehension. So the more properties you add to a concept, the more predicates you add to a concept, the narrower its extension gets. Until I think there was this ideal of the complete concept, right? Every individual thing would have a complete concept, sort of in the end. And here, I mean, I would imagine maybe he'll discuss this later, and I'm jumping the gun, but I would imagine that for Simondon, then it's the opposite. That as we enlarge the comprehension, we can also enlarge the extension of a concept, and that would seem to be then the point of difference from inductive thinking. And there's also the last sentence that I think it was Alyosha who read it, where he says, scientific thought is not a pure induction, achieved by classification found on differences, but it is also not an identification at all costs. It is instead a distribution of the real according to a measure, a mutual criterion of extension and comprehension. It seems like the measure will be doing some important work here. And that's what I'm trying to wrap my head around that a little bit more.
Yeah, the notion of measure here has to do with the continuity that we were talking about a little bit earlier. In the case of the electromagnetic spectrum, it's the measure of wavelength or frequency, and the way that measure is what underlies the various properties of reflectability, for example, and it's that measure that is more fundamental. It's what explains the properties that are manifested by the phenomenon in question. So that rather than starting from the properties and then abstracting away from the individual to get to the species and then the genus and so on, we are taking those properties and showing this underlying measure that brings about those properties, or the measure. We're measuring the place of the entity or the phenomenon in question in relation to this continuity. And yeah, so I think we can understand this measure as the identity of rapports, so that there's a certain measure of the wavelength of the radiation, and then there's a measure of the fine grainness of a lattice or a crystalline network or whatever it is. And there's a identity between those two relations.
I just also want to bring up measure is kind of an interesting word because it maybe incidentally kind of calls back to probably one of the basic insights that as I understand it, of like quantum sciences and of quantum mechanics and whatnot, that on the most basic level that in those experiments that we I think know pretty well, with the slit experiment and some other experiments as well, that there is no separation of measurement and the phenomenon observed, and that measurement it affects what is observed. It actually helps create the result that you get. And so I could be inferring this, but I think on a larger scale, the notion of measure might be important for Simondon, because again, if you are only operating in an old school kind of traditional analogical way of thinking, then measurement is kind of just a convenient heuristic, a way of looking at something that helps you understand the thing. But if knowledge is individuated in the process of trying to know individuation or understand individuation, then it goes back to I think what you said earlier, Aldreams, that of having to be intimately sort of in the process in order to understand it, that you can't there's no measurement that isn't itself part of the process of both creating or affecting the thing being studied, but also understanding that, I guess, the continuum at the end of the day, if that makes any sense. So and again, if we look at the science example that he brought up of sound and smell and whatnot, that illegitimately starting from concepts alone led to a kind of almost scientific dead end, whereas there's a need for the measure needs to almost fit exactly and grow alongside of the thing being studied. So there's a co-individuation of the knowledge, and to partake in the individuation, it just goes back that there has to be an individuation in thought in order to even partake of it. So that pure kind of analogy, it's no longer just a question of thinking interesting things about something, but participating directly in its reality, I think.
Yeah, I think that's maybe a good place to stop for today. We'll pick up from here next time. We're almost at the end of the subsection, so it's kind of too bad that we didn't get to finish it. But yeah, so we'll finish the last couple of small paragraphs of the subsection next time, and then we'll get to the next section on particle and energy. And so we'll see again, like two of the subsections of that section are on induction and deduction. So we'll see more on the relation between transductive thought and inductive and deductive thought next time, and probably the following time after that as well. So thank you everyone for your participation, for your questions and comments. I think maybe next time we can probably do without server muting everyone to start with. I just wanted to make sure we didn't have a repeat of last week. But thanks everyone, and see you all next week.